Okay, we're up and running. So just as a recap from last class on exponential growth and decay, we started with we need to know this formula, y equals CE to the KT. So we're going to take that formula and we're going to give you guys a little bit of time and we're going to have you start class today with this question. So let's read real quick and make some sense of it. For 4 months after it stopped advertising, a company notices that its sales dropped from 100,000 to 80,000 per month, respectively. If the sales follow an exponential pattern of decline, what will they be? In other words, what will the sales be after 2 more months? So the information you should be able to pick out of this is at the beginning of this story is t equals 0. So at t equals 0, it was 100,000. And then after 4 months, t equals 4 would be 80,000. And then the question is saying after 2 more months, what's going to be the situation when t is equal to 6? Okay. So I will stay quiet here for about 4 or 5 minutes, and then we will talk. So using the exponential growth and decay formula, which is y equals CE to the KT, go through and see if you can come up with an answer. It's not going to be a particularly pretty answer. So if you want to use a calculator at the very end, you can, or you can just leave it in its unsimplified form. Okay. All right. So we'll talk in about 5 minutes. Okay, so anybody have an answer they want to share? See if they're right. Any brave souls out there?
I got, yeah, same.
What's that? I'm sorry.
I disagreed to someone who typed in
Oh,
that.
in chat. Okay, I got you in chat. Let's see, 71,000. Yeah, I got the same exact thing, 71,554. It sounds good. All right, let's check out the math and that and see if this follows. So the first thing we should have been doing is A is equal to CE to the KT. And then we're plugging in 0 and 100,000. So when you plug in 0 for T, e to the 0, that's going to go to 1. So we know our C value is 100,000. Okay, we carry on. And now we're going to plug in 4 and 80,000. So that's 80,000 is equal to 100,000 e to the 4K. And then going through with that math, divide by 100,000, that's 4/5 is equal to e to the 4K. And then do your natural log of both sides. So natural log of 4/5, when you natural log e to the stuff, you got the stuff, and divide both sides by 4. So that's going to be natural log of 4/5 over 4, or you could call it 1/4 natural log 4/5. And then finally, we want to go through this, and we are plugging in a 6 for T. So when you do that, you've got 100,000 e to the 1/4 natural log 4/5 times 6. And you can simplify that if you want, or if you head to your calculator, that gives us an answer of approximately 71,554. Does anybody have any questions on that?
Should we run to 3 decimal places?
Yeah, so if it's a calculator question, and this was like calculator free response or calculator multiple choice, we'd have to see what the question is saying. So when in context of this problem, it seems like the sales were being given in whole numbers, so that's why I did it. There wasn't a whole lot of context given. When in doubt, yeah, just do 3 decimals because you can't go wrong by doing that. So I didn't do it just because it seemed like this context was whole numbers. But on the AP exam, any free response, yeah, do 3 decimals. Any other questions? All right, then we're going to tackle some free response here. So I will give you a second. If you want to copy that into your notes, feel free. So take a second and just go ahead and copy this down. Fish are being introduced into a man-made lake. The change in the rate of fish with respect to time is directly proportional to 900 minus f, where t is measured in years. When t equals 0, there are 400 fish in the lake, and 3 years later, there are 600 fish. All right, and question 1 is write and solve the differential equation that describes the situation. So this is going to be a ton of math. Do you guys need more time to write this down, or are we good? Keep going. I will take your silences. We're ready. All right. So what is the situation that we're working with? Fish are being introduced. Okay. The change in the rate of fish F. So that's like the rate of change of F. So the rate of change of F would be dF dt. And it says the rate of change is directly proportional to 900 minus F. So that's K, and then 900 minus F. All right, so that would be our setup. The rate of change of fish is directly proportional to 900 minus F. And the whole key to this, and we're going to do way more of this coming up next unit after we get through your test next week in AB, The next thing we start is on differential equations. So you guys are kind of getting ahead of things now with this lesson. So to solve a differential equation, your goal is to get the variables on the same side. So we want to get this 900 minus f to the left. But now the question becomes, well, how do we do that? So these two things are being multiplied. So I need to divide this over. So if I divide this over, this is really 1 over 900 minus f df is equal to k, and then I'm going to move the dt over. Now I know k and dt aren't quite the same, but that at least separates it for us. And now our goal is to integrate both sides. And remember from earlier, last class, k is just going to be like a constant. Okay, so currently we need to integrate both sides. And if you have questions during any of this, guys, just yell out and ask me stuff. So to integrate the left here, you've got two options. If you can recognize how to integrate this, I'm okay with it. The safer route is to do U substitution. So what kind of answer do you think we're going to end up with here? Does anybody recognize any kind of pattern? Like, what do you think we're going to end up with?
ln.
Yeah, it's going to involve natural log. Yeah, but now the only reason I said be careful is because this is a negative. So if we do U substitution, that's 900 minus f. So du is going to be negative 1 df. And then that would make df negative du. So when you do this, this would be the integral of 1 over u, and then it's negative du. So the part you got to be careful about is this extra negative symbol. And then that's the integral of k dt. So when you integrate this, it's definitely going to be natural log, but it's natural log with a negative sign out front. And then that's going to be 900 minus f. Okay. And on the other side, when you integrate that, that's going to be kt plus c. Any questions there? All right, so up above, our first piece of information is when t equals 0, there are 400 fish in the lake. So we're going to use that piece of information next. When t equals 0, there are 400 fish in the lake. So let's plug that in. Negative natural log. If I put a 400 in there, that's going to make this 500 is equal to, and this is when t is equal to 0. So that's just going to leave us with c. So now I can see that c is equal to negative natural log 500. All right, so let's toss that back in. Negative natural log 900 minus f is equal to kt minus natural log of 500. That's our c now. Okay. And we have another piece of information from up above that says when t equals, well, it doesn't say t equals, but 3 years later would be t equals 3, and now there's 600 fish. So we also know that at t equals 3, the fish value is 600. Okay, so let's plug that in. That's negative natural log. Put a 600 in, so that makes that 300 is equal to, we're going to put a 3 in for t, so 3k minus natural log 500. All right, and we're going to go ahead and solve this for k. So I'm going to take the natural log out of there, so I'm going to add that over. So now I see natural log 500 minus natural log 300 is equal to 3k. Okay, so you need to know some logarithm properties here. When you subtract logarithms, you're really dividing them. So this is 500 divided by 300. So that's natural log of 5/3 is equal to 3k. And then I'm going to divide both sides by 3, and that's our K value. And then I'm going to write that as K being equal to 1/3 natural log 5/3. So we'll circle that one. Okay, does anybody have any questions on how I have found C and found K?
How does this look if you did the like arctan thing?
Arctan thing.
I thought that's what the integral was because it's like 900. It's like 30 squared. And
Okay. So this has to be a squared variable for arctan to work.
okay, got it. Thanks.
But if that was the case, then yes, that well, and then the other thing though that you need, so there's a couple problems. This also has to be a plus sign because it was a squared plus u squared. So technically, if this was a plus sign, we could go ahead and do something with that because you could have made this like what you said. That's a good pickup, actually. You could have said that was 30 squared, and you could call that the square root of something, but this has to be a plus sign for arctan to work. Okay, so let's head back up to the top here and plug in what we've got. So what is that? We have negative natural log of 900 minus f is equal to, and then it was kt plus c, but now we know what k is. K is 1/3 natural log 5/3, so that's k t, and then plus c, and c is negative natural log 500. Okay, so we are getting there. I'm gonna get rid of this negative sign because this doesn't help anybody out front with that negative. So I'm gonna go natural log 900 minus f is equal to, and then let's call this negative 1/3 natural log 5/3 t plus natural log 500. So that was just getting rid of that negative sign up front. I don't know that you necessarily have to do that. That's just kind of how my brain works. Okay, we're going to try to solve this. So we're going to convert natural log to a logarithm of base e. So if we do that, I don't really want to write all this out again. So just pretend that this is log e. So it's going to be, well, let's just do it. Never mind. I want to make sure you can see it. Okay, so think about our pieces here. Now I get it, this is a mess, but this is log base answer equals, and then this whole train wreck would be the exponent. Log base answer equals exponent. So the base gets raised to the exponent, and that's equal to the answer. Okay, well, something that jumps out at me immediately is this natural log over here. If we rewrite this as e to the negative 1/3 ln 5/3 t e to the natural log 500. Look what happens. This and this, when you multiply them, you really add these, but this allows me, what is e to the natural log of the stuff? That is the stuff. So we can bring a 500 out front now. Forget about that term and say this is 500 e to the negative 1/3 natural log 5/3 t is equal to 900 minus f. And then to solve this for f, I'm going to add the f over. So f is equal to 900 minus this mess, which is 500 e to the negative 1/3 natural log 5/3 t. And that is us solving the equation for f. So let me zoom out here so you can see the whole thing. So when you're watching the recording later or whatever, if you want to take a picture now, that's the whole deal. Do you have any questions on that whole page of math? Good news, when you get into AB in a week or so, differential equations are about 50 times easier than the one you just looked at. So if this makes sense, you're in pretty good shape. Natalie, did I see you coming on to say something?
Yeah, what did we do with the negative in front of the natural log?
Up here?
Yeah.
I just didn't like it, so I divided both sides by it. So when I divided that, that's why this one turned negative and that one turned positive. I don't really have a good answer other than I didn't like it. Do I have a good answer? Let me see. I just knew that my brain didn't like it. Yeah, I think the reason I could say that my brain didn't like it is because I saw down the road here that this was going to be log E. And then the thing that you're turning to log E, we never want that to be negative. That's kind of hard to work with. So it's better off if the term that you're going to turn to log E is positive. So basically, we just changed the sign of all the different terms. Does that make sense?
Mm-hmm.
Okay. Anything else, guys? Questions on that? Okay, so that was the hardest part of it all. Let's see what else we've got. Part B, find the fish population in another 3 years. All that means we have a formula now for fish population. We know the fish at any time is equal to 900 minus 500e to the negative 1/3 natural log 5/3 t. And all this means is in another 3 years is t equals 6. So this is just asking us for f of 6. So 900 minus 500 e to the negative 1/3 natural log 5/3 times 6. And nobody knows what that is, so you would need to go fire that into a calculator. I will save you guys some time. I've already done this, so that would work out to approximately 720 fish. So that's pretty simple. That's just recognizing what your formula meant that you solved for up above and then plugging in a 6. Any questions there? All right. And the last piece, evaluate the limit as t goes to infinity. Okay, this has some important properties in it. So if we do the limit as t goes to infinity for f of t, well, we have a formula for f of t, and it's 900 minus 500 e to the negative 1/3 natural log 5/3 t. And it's the limit as t goes to infinity. So I'm going to give you guys like 60 seconds just on scratch paper or whatever. Think about what's going to happen as t gets super, 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 super big. It heads to a gigantic, whatever infinity means to you, a million, a billion, a trillion, whatever. As this number gets gigantic, what's the result going to be of all of this? So take about 30, 40 seconds or so and think about it, and then we'll talk. All right, anybody have any ideas, thoughts, comments? Think any idea what would happen as this gets really big, the t value?
Because there's a negative in front of the exponent, I think it's gonna get really small.
Okay, so yeah, that's exactly right. So if we did that, that's going to be 900 minus 500. And then I'm going to write this as e to the negative So this is going to become a gigantic number, right? E to the negative big number, if that makes any sense. Because this is just going to become a gigantic big number, but it's a negative gigantic big number. And negative exponents mean to flip this. So this is really going to be 900 minus 500 over, since it's a negative exponent, it's going to flip to be 500 over e to the big number. So if you have 500 over a billion, that's the same thing as saying that it's heading to be what? What's the end result going to be of this term as it goes towards infinity, Taylor?
It's gonna get smaller and closer to 0.
Exactly. So this term is heading to 0, which means we can just get rid of it because it's going to be approaching a number so small that it no longer exists. And therefore, the limit answer to this question would just be 900. And then the meaning of this is going to be, as time goes on, the population of the fish is going to approach 900. Because you're seeing that it's going to approach a constant number because the other piece is going to disappear. So in terms of its result, or the meaning, as time goes on infinitely, the number of fish in the lake would approach 900. What do you think, guys? Any questions, comments? So that kind of wraps up exponential growth and decay. You've now got 4 or 5 examples and a full free response on it. Mohammed?
So my question for the last part, I thought it would be 900 minus 500, and then the big number in of itself would be positive, because natural log of 5 over 3 is also a negative number, so like the negatives cancel out.
Whoa, hold on. Say that again. Natural
For the exponents that go along with e in our last part, I believe it would be a positive big number, because natural log of 5/3 is also a negative number. So like our negative.
How did you get that? What are you taking for? I don't have a graphing calculator with me, but just off my phone, I don't know if you can see it. I typed in natural log 5/3. I'm getting a positive number.
Okay.
Where did you, or how did you type it in? Natural logs should always be a positive result. So like, just to kind of explain to you off to the side, what that means. Let's forget the whole problem. Let's just say natural log 5/3 and just analyze what that means. So I don't know the exact number, but natural log of 5/3 means log e 5/3 equals x. So that's like saying e to what power is equal to 5/3. Now, I have no idea, but e is approximately 2.71828 to the x is equal to 5/3. So there's some number out there that if I raise 2.71 to that power, it's going to give me 5/3. So just for some, further background, no matter what this number is, it's going to be e to something is equal to a number. And when you're raising e to something, think about your choices. If I raise e to a positive, I get a positive. If I raise e to a 0, I get 1. If I raise e to a negative, I just get 1 over e to that number. So there's no real way to come up with a negative number for natural log. And that's also the same reason that whenever you integrate 1 over x, that they make you put absolute values around what you get, because it's kind of like saying, I guarantee the result of that natural log will be positive. So, hold on, Taylor, what did you say? Wait, wouldn't a natural log? Let's see. So you're saying natural log of something between 0 and 1. Okay, so natural log of a half. So if we did that, that's going to be e to the what is equal to a half. So e, we don't know what it is, but if you had 2.71828, I don't know that we would want a negative number in there. I could see it being a fraction because that would make it smaller, but in terms of a negative number, I don't think.
Mr. Baker, if you rewrite it as ln of 1 minus ln of 2, doesn't it become negative?
I'd have to think about that because I get what you're saying.
If you graph like L and X, part of the line is.
Yeah. I mean, the graph of it drops down to negative, but in general, when you do e to a power, I mean, so natural logs, well, I don't want to confuse people with my definition of this because they don't get too crazy with this, but natural log of X is log e X. So it's basically saying e to what power is equal to that. And so e itself is never going to end up in a negative. What did you type in whenever you did in the calculator, whenever you came up with?
Yeah, you get a negative if you do ln like 0.5 or something.
Let me see here, negative. Think about my explanation here on that then. I'll have to think about that when we get back to you guys here. I don't want to send the recording on forever. Let me think about what you just said, because this answer came right out of a textbook. I didn't, or more specifically, it came from Mr. Kokonis to be more accurate. He's the one that did this with me last year. Let me think about what you guys just said, and I'll get back to you on an answer though.
Well, no, Mr. Baker, that answer is correct.
Well, when you typed in natural log of 5/3, you didn't get a negative, correct?
Correct, because
Okay.
5/3 is greater than 1.
Yes. Maybe I misunderstood your question.
Oh, I was at one point you just said that like a natural log should never produce a negative answer, and I think it can.
Well, yeah, I think what I was trying to say is that whenever you're doing like natural log, when you integrate it, the idea is saying that when you integrate 1 over x, that you come up with natural log absolute value x, because this number should always be positive, is what they're trying to gun for. Let me think about this. I'll get you a better explanation when I'll work out all the different scenarios, and I'll get you a full working explanation of this for our next get together.
Sounds good.
Sound good? All right. Do you guys have any questions though on the big picture, which is differential equations, solving this whole thing? Anything from down here? Just for the most part, does that all make sense? Okay, cool. I will work out various scenarios. I'll get you a good explanation to answer your guys' question on that. Other than that, have a good night. We'll call it there. And our next get together is what's today? Thursday. So Sunday night, I believe the thing says we're going to start Euler's method, which is a pretty straightforward, easy lesson. There's normally not too much trouble with that. So we will do that on Sunday night. I will see you guys then.
Thanks. Have a good night.
All right. Thanks. See ya.
Thank you.
Sorry, Mr. Baker, I didn't interrupt the conversation. I think X only can get like natural numbers, not fractions. But when it's a fraction, like let's say 2/5, it will be like ln2
Yes.
negative ln5.
Yeah, what I had in my mind was just the integration process of it, which is they want the absolute values of them. If you put certain specialized numbers in there, it will produce a negative. I'm going to get a visual for you guys and work out the couple different scenarios. I just didn't have it at the top of my mind right now. But yeah, it can happen. It's just rare that you'll see that. I'll get you guys a graph next time we're here. We'll look at it.
Thank you. Bye.
See ya. Have a good night.